Okay, what you see here is a screen of an oscilloscope. An oscilloscope translates sound waves into something we can see, as you can see on the screen. It's always handy if you want to measure something, if you want to get your guitar tuned, for example, or your piano, you can use something like this. As you see, if I want to do measurements on my voice, it's going to be really hard. What is the frequencies? And it looks like I see more waves, so probably in my voice there are more frequencies as well. So that's going to be quite hard to do so. So to make life easy, we're going to do some measurements just using one frequency. Therefore I put on sine wave amplitude 5 volts. And now you can see you can do some measurements. As you see, there's a horizontal and a vertical scale. Looking at the horizontal scale, you see it takes two squares to complete one wave. And every square takes 1 millisecond to pass. If I would change the seconds per division or seconds per square to 2 milliseconds, you see that now it takes 2 milliseconds in one square, so each wave is in one square as well. So one completed wave is completed in 2 milliseconds. As it was before. Now I'll change it back to 1 milliseconds. And you see now we need two squares to complete one wave. Each square is 1 millisecond, so the complete wave takes 2 milliseconds to complete. If I look down here, you see I got 5 volts per division. That means that each square, each division in the vertical x has got an amplitude of 5 volts. That means how loud the sound is. So one division is 5 volts. If I would change it to, for example, 2 volts, then it means one division has got 2 volts. So the whole wave is 2.5 division, so 2.5 times 2 gives me still an amplitude of 5 volts. And if I would change it, for example, to 10 volts per division, you see that the wave of 5 volts, because the wave is still 5 volts high, only has got half a division.